something went terribly wrong. At the beginning of the Triassic period, 245 million years ago, the highly developed and greatly diversified proto-mammals began to die off in record numbers. The larger they were, the more vulnerable. And at the same time, the first little dinosaurs were mysteriously thriving. The dinosaurs began a long conquest of the planet. In battle after battle, they pushed the proto-mammals to the brink of extinction. The proto-mammals' dynamic and seemingly unstoppable rise from lizard-like Ophiachodon to sailback Dimetrodon to the truly warm-blooded and dog-like Cynoognathus suddenly faltered. To survive, the late proto-mammals, like Thrinaxodon, were forced to downsize. They held on to life in forms no larger than a rodent. Reduced in size and pitched against the skillful dinosaur predators, proto-mammals had to adapt to nighttime activity to survive. Now technology is revealing what these small creatures were doing in the darkness. They were getting smarter. With lasers, X-rays, and CAT scan images, Tim Rowe and his team can actually get inside the head of a proto-mammal.
Here's a little Thrinaxodon skull. Be careful with it.
They're discovering the story of how mammalian intelligence developed. Rowe has studied extensively the skull of the advanced proto-mammal, Thrinaxodon.
The CAT scanner uses an X-ray beam to effectively slice this specimen as if it were a loaf of bread, simply slicing it from bottom to top in this orientation. And what you're looking at is a single slice that's about the thickness of a piece of paper that was taken through this skull. Here's the next slice, a little higher. Here's the next slice, a little higher yet, a little higher, a little higher. This slice shows the matrix here in dark. It shows the bone and teeth in light. And by going through this slice by slice by slice, we can see all kinds of details of the anatomy of Thrinaxodon. And with a computer, we can not only slice through this a frame at a time, but we can animate it. And here you can see a passage from the bottom all the way through the very top of the skull. Here's the very top of it right there. And that's it. Go all the way through this specimen automatically like that. Visualize the internal details, the external details in just a few seconds.
With its small head and pointy snout, this mean-looking animal was one of the most advanced of the proto-mammals. Small but deadly, it had a vicious set of teeth that could shear and slice its prey. It stole through the forests, bullying and killing animals its size or smaller. As proto-mammals went, the size of its brain made it a genius, but compared to the brain of an opossum, it was a mental midget. Yet even with these new technologies, many mysteries about the development of mammals remain unanswered by the fossil record. We do not know when many significant mammal traits developed, such as mothers giving live birth instead of the reptile trait of laying eggs, or when these mothers developed mammary glands to suckle their young. Many of these mysteries could be answered if we had samples of soft tissue from the extinct animals. Unfortunately, fossilization preserves only the bones and teeth, rarely the soft tissue that surrounds them. Whether or not proto-mammals had developed fur by the time of the Thrinaxodon is a hair-raising question that has spurred serious debate. Nicholas Houghton thinks they had.
There's great big holes in the front of its muzzle, like this. These holes were passages for blood vessels and nerves, which may have been the innervation and blood supply of whiskers, which are sensory organs. But whiskers are specialized hair, and if they had whiskers, maybe they had hair also. So a living Thrinaxodon may have looked even more like a possum than their skulls do. In other words, they were warm-blooded and hairy.
But the latest CAT scan images lead Tim Rowe to think that Thrinaxodon had little or no hair.
This area of the brain is involved in mapping the sensory input from the hair over our body. In Thrinaxodon, that region is missing. So if Thrinaxodon did have hair, it didn't have as much hair as modern mammals did. Hair didn't provide quite the sensory input. If it didn't have as much hair, it also wouldn't provide quite the insulation that it provides in modern mammals. So if Thrinaxodon did have hair, it wasn't keeping it as warm as the hair keeps modern mammals. Thrinaxodon probably wasn't warm-blooded quite in the sense that modern mammals are.
In the beginning of the Jurassic Age, 210 million years ago, we see the first full mammals, creatures like the Morganucodon. It was as small as a squirrel. For 145 million years, mammals grew no larger. Until 65 million years ago, when in a twist of evolutionary fate, the great extinction killed off all dinosaurs. With the dinosaurs out of the way, mammals rapidly evolved, and some grew in size. The millions of years they had hidden themselves had paid off. They now assumed domination of the planet. The enormous diversity of modern mammals owes its evolutionary heritage to Dimetrodon and the other fantastic proto-mammals from virtually the beginning of life on land. In this incredible tale of the sail came the traits that make us mammals and make us human.